Hmm.
Hi, my name is Kahini Desai. I'm in the 11th standard in Cathedral School from Mumbai, and my project is regarding predicting star types. So essentially, what happens is, for this, we've taken a data set from Kaggle, and we take input from the users regarding the temperature, luminosity, absolute magnitude, star color, and spectral class, and then they predict the star type using a type of supervised learning. So the picture shown on the side is a picture of the code that I've made on Python to predict the star type. This is the data set. As you can see, it has a very wide variety of values. So it can give greater accuracy, which is 240 rows and 6 columns. The 6 columns include temperature, luminosity, radius, absolute magnitude, star colors, and spectral class. And the minimum and maximum value is given in each. So it shows the range of the data that it can take, and the user has to input so they have a better idea. Um, this is just more about the data set. As we saw earlier, there was temperature. So that indicates that hot stars are blue and cold stars are red. And every single input by the user is supposed to be taken in Kelvin. The luminosity is a measure of the amount of energy radiated on the star per second. And the absolute magnitude would is the if it were viewed at a standard distance of 10 parsecs, since the distance measured is really large, it's measured in parsecs and light years. Last but not the least, we have spectral class, which have like approximately 7 spectral classes, which tell us more about the color, temperature, and the special features, essentially what the star consists of, so it can give a better output. um, so these are what it is predicting, essentially, the type of stars. So we have brown dwarf, red dwarf, white dwarf, main sequence, supergiant, and hypergiant. So based on the input of the users, the code will give an outcome and it'll be much more efficient. That's why it helps, because it helps in astronomical observations, research purposes, and celestial events, because it's more convenient and efficient that way. Um, Now, to give a more hands-on experience, I'm going to show you the code that we got and essentially what we did. So the data set was taken from Kaggle, where a bunch of data was given. Then we went to Pixida, where essentially we trained the data. And out here, you can see there's something called random forest classifier. It basically, what's after training the data, what it does is it classifies the data to give the highest accuracy. So out here, the metric value is given as 97.91, which is a pretty accurate value as compared to k neighbors. And that's why it chose random forest. And then to monitor the data to check whether it's actually working and whether it's trained, what you do is there are already values entered, and there's 5. So 5 in this case would be hypergiant, and the shortcut of this is given out here. There's 0, 1, 2, 3, 4, 5. Um, Now coming to my code, what it is if I run it, it shows me enter my name, pretty basic. I enter it. And now, as I saw the range of data was already given, let's say my temperature is like 6,000 Kelvin. My luminosity is 0.001 of 7. Let's see that. My radius is 400. My absolute magnitude is 6. And since my star colors, there are many. There's red, blue, yellow, orange, yellow, white. So I'm going to say yellow, white. Let's see what it does. And my spectral class, there was 7. I'm going to say it's O. My star type is 4. I have to re-enter it to show me what kind of star it is. So in this case, it would be a supergiant, which essentially tells us what star type it is. So all of the print statements and the input statements, all of that is essentially to take input from the user and give something back. So it makes it much more efficient. Thank you.